solution to this equation, this factorial congruence equation. And of course, 35 factorial is a large unpronounceable number. But what we're really trying to find right here is a number x where x is a prime, such that this is true. And I'll just rewrite this in perhaps a more familiar way. This is the same thing as saying 35 factorial minus 1, okay, is going to equal to some multiple of x. Okay, so I'll just write that mx, where m is some other integer. And again, folks, that reads mx. M is a multiple, or it's a multiple of x. 35 factorial minus 1, this huge number, is some multiple of x where x is a prime. Now there's a result here that's very, very useful, it turns out, to help us do this, and it helps us get to a more familiar result. You'll notice right here that this circled piece is definitely congruent to 0. Okay, the circled piece is congruent to 0 simply because p squared minus 2p is a multiple of p. Okay, and so that's why this part just goes away and we're left with this result right here. P minus 1 times p minus 1 is congruent to 1 mod p. Now what that means is that these p minus 1 is its own multiplicative inverse. So let's go down just a little bit here and see if we can find some results that will help us get along right here. Now, a lot of you probably already noticed that the result that kind of cries out to be used is something called Wilson's theorem. And it goes like this. It says that p minus 1 factorial, where p is a prime, is congruent to negative 1 modulo p. And this is for any prime. Okay, now, so let's take a look at how this is going to be helpful. Now, y'all, what I'm going to try to do is piggyback this result right here. Now, first of all, let's rewrite this in a way that makes it more clear why this result is important. We can rewrite this is p minus 1 times p minus 2 factorial. Now that's starting to look sort of familiar to the original problem. So we can write this as p minus 2 factorial. And just for the sake of cutting down on the writing, it's understood we're doing mod p right here. So this is congruent to negative 1. Okay, now, so again, we're going to see why this part right here is handy. What I can do is multiply through by p minus 1 right here on the left-hand side. Okay, let me just see, because that'll just be all congruent to 1. See, p minus 1 times p minus 1 is congruent to 1, so I can multiply by that and then replace it with what it's equal to on both sides. So let's move down just a little bit here. Okay, so, and I'll go ahead, I could just leave it out, but I do want to show you that step. This means the very same thing as you can write down p minus, and multiplying p minus 1 times both sides of the congruence. So we have p minus 1 times p minus 1 again. Okay, now, so we still have the p minus 2 factorial here. But now y'all notice that what we did here, this is just, you can treat this exactly like an equation in many regards. I multiplied this side by p minus 1, so I have to do the same thing. I have to multiply this side by p minus 1. But when you do that, you get congruent. And I'll put in parentheses just to make it a little nicer. You can, that would be 1 minus p here. Okay. But notice that this is congruent to 1. This is congruent to 1. Okay, and we're still mod p, folks. That's because 1 minus p minus 1 is negative p, but that is a multiple of p, right? Okay, now this part over here, though, this part over here just becomes 1. So let's write that down. Remember, p minus 1 times p minus 1 is congruent to 1. Let's back up here. P minus 1 times p minus 1 is congruent to 1. We'll use that fact or that hint. Okay, and so this part right here just becomes 1, and I'm doing that for emphasis, 1 times p minus 2 factorial is congruent to 1, and I'll go ahead and write the modulo in this time, mod p. Okay, but let's take a look at the original problem. Okay, the original problem was, can we find an x that will meet the criterion here of 35 factorial is congruent to 1 mod x, where x is prime. Again, 35 factorial is congruent to 1 mod x is the problem we're trying to solve. Now, if you go down here, if you want to write this, we'll just replace this right underneath it with what we're seeking here. So this would be 35 factorial is congruent to 1, and the one that makes it work obviously is mod 37. Okay, and that's just by inspection, right? Mod 37. Mod 37. So you see, folks, again, that totally fits the bill here. 37 minus 2 is the 35 you see right here. So our answer here would be, in this case, this was our x, so our x is equal to 37. Okay, folks, I should have kept that on the same screen, but the solution here would be x equals to 37. All right, y'all, I hope you enjoyed that. I thought that was pretty cool. We had to prove kind of an intermediate result that was similar to Wilson's theorem, and we got our answer.